Thank you. I'd like to start off with giving you a quick review of the 6 national wildlife refuges that we manage along the Oregon coast. And keep in mind when you see these photographs that including myself, we have a grand total of 9 permanent employees for these 6 refuges, which span about 320 miles of the Oregon coast. So Three Arch Rocks is the oldest refuge west of the Mississippi River. It's only 15 acres. But it was set aside back in 1907 to protect about 250,000 seabirds that breed there. This is the Western Rock or Shag Rock, and all those little white and black dots on top of the rock are 126,000 nesting common murres. And to give you a regional perspective, there's 13 to 16,000 murres breeding in the state of Washington and a similar number in British Columbia. Cape Meares National Wildlife Refuge was established in 1938, and it protects about 100 acres of old growth forest, which is a really rare commodity these days along the coastline. You can see the nice, smooth looking industrial forest lands behind the Cape there. And then Oregon Islands National Wildlife Refuge spans from Goat Island here near Brookings on the near the California border all the way to Seaside in the north part of the state. It includes 1,854 rocks, reefs, and islands. It's also a wilderness area, very important to marine wildlife, and closed to public access at all times. So these rocks are obviously very scenic and spectacular, but they're also home to a lot of migratory birds and marine mammals. And so I worry about the potential of climate change to cause weather shifts that would affect upwelling, which is our primary productivity along the west coast, and how that would impact wildlife that we're trying to protect. And also ocean chemistry, ocean acidification, how that might affect our environment and species like these black oyster catchers. We have tens of thousands of pinnipeds on the refuge along the coast, including the largest breeding site for stellar sea lions in U.S. waters south of Alaska, a species that was recently delisted last December. And then currently we're concerned about the increasing wave height and storm surge overtopping these lower islands, particularly islands that have soil and vegetation. And these are islands that are used by burrow nesting species, so it's the only place they have to breed. And this is a species that most of you in this audience will never get to see. It's a Leach's storm petrel. They are nocturnal at the colony. They breed underground. During the day, they're 50 to hundreds of miles offshore. What's in the future for this species if we have this loss of habitat? And then the charismatic tufted puffin that people love to see. This species is also a burrow nester, and it's declined all along the west coast, the lower 48 states, and in Oregon we've had about a 90% decline, and there's no smoking gun. We don't know what the situation is with this species. So we also manage 3 estuarine refuges. This is Banded Marsh in the lower Coquille River. This watershed has suffered the greatest tidal marsh loss in Oregon at about 95%. The only part that remained was the salt marsh down here that we acquired. And then we also acquired this area, which was diked and managed as pasture for about 100 years. This estuary, like many of them, are very important to migratory shorebirds as refueling stops. This is the what we call the Nyleston unit, where we did the tidal marsh restoration project in 2011. We restored about 418 acres of tidal marsh, so it was the biggest project in Oregon so far, and an attempt to gain some of this habitat back that is so important to so many estuarine-dependent resources. At Nestucca Bay, this estuary has suffered about a 70% loss of tidal marsh, and the tidal marshes that remained were actually in private ownership, so we've acquired those and put those in public ownership, but we're also actually managing diked pasture lands on historic tidal wetlands, and the reason for that is several species of geese, rare forms of geese that we're managing there, and now 4 other subspecies that are very abundant and causing depredation issues on private dairy lands. So we're trying to grow as much grass as we can on refuge for these birds, but how long can we stem the tide? At what point are we going to have to switch from managing dikes and water control structures to doing restoration and moving on with other management? So at Siletz Bay, we have a really popular float trip that we guide around the refuge. as well as very important to migratory birds. And you see a theme here. I'm showing a lot of bird pictures. When I'm dealing with the public in the field and I talk about intrinsic salt marsh values, they don't get it. They can't see it. It's hard to understand. Most of the good things that are happening in the soil, in the vegetation, or underwater. So we use these species to talk about the value, to direct value to wildlife like waterfowl or peregrine falcons or other wildlife that you see on these areas. So I wanted to know how climate change, particularly sea level rise, is going to impact this refuge at this location. So we've partnered with the U.S. Geological Survey to get at that, and we've been working with USGS since the 1980s. Because of our limited staff, we can barely keep up with the management, so we can't do science. We don't have the time or the horsepower to do that. Here you see Silet's Bay. It only lost about 40% of its tidal marsh, so it's doing better. U.S. Highway 101 here. This is our study area. This is natural tidal marsh. The only perturbation in the past was grazing, except for this landfill here, which is an alder forest now from this South Florida development that was stopped in the 1970s. And then we've restored about 100 acres of this was diked pasture land, and that was restored in 2004. That's a reverse view of the natural marsh, and you can see the area that we restored has subsided some, and so it's more deeply flooded. And then this is a photograph of that same area during the king tide. So this is what it looks like now. What's it going to look like in the future, and how are these habitats going to transition with increasing sea level? And this is just a shot at the lower end. This is some really nice high or low marsh out here, and at what point might we expect to lose that to mud flats? So now I'd like to invite my partner here to.
Thank you, Roy. So this project has lots of partners and co-PIs. It's a very large project. I'm going to focus today on the property that Roy manages. But in addition to USGS staff, we support graduate students at Oregon State, UC Davis, and UCLA, either graduate students and postdocs, and then lots of fellow PIs. So briefly, there's been lots of talks about sea level rise. I'm not going to really talk much about this, except all the modeling results you see today. We use the NRC 2012 results for Oregon. And you can see that they have low. So Oregon is up here, low, mid, and high. And I'm going to mostly show results today for mid and high sea level rise. So this is the overall program that I run right now at the USGS. So you can see that we have about 17 estuaries. That is over almost 2,000 hectares. Our basis of our program is collecting intensive local site conditions, so they're relevant, so the results are relevant to managers at a local scale. However, all the methodologies across the sites are the same, so they're comparable amongst each others also. So people like Roy or regional managers can also compare all their properties. So this is my only data slide because of the quickness of this talk. But really what I want people to notice is that we collect a lot of data at the site. So we do RTK GPS elevation surveys, vegetation surveys while we do elevation. We monitor sediment and accretion. All sites have water level loggers deployed, so we're establishing local tidal datums and inundation patterns. For example, Silet's has 3 water level loggers deployed in that. They've been out for multiple years at this point. We do bathymetric surveys to the local areas, and then a lot of the analysis is done in GIS. And then to tie it back to management, today I'm going to just talk about the plant communities, but then we can tie it back to the habitat requirements. So it's a large project collecting a lot of data. It's done in multiple phases and tailored to what the local resource manager's questions are. So really, the modeling results I'm going to show today, we developed the warmer model. It's published here in San Francisco Bay, calibrated to the San Francisco Bay estuary. And so now Kevin Buffington, a PhD student at Oregon State, is modifying this modeling approach for other estuaries along the Pacific coast, so Oregon and Washington and other areas. So you can look up into more details, but the reality is that we take core data and all these different parameters are put into the model. So very site-specific, relevant at the local scale. And there's a lot of sea level rise modeling that's been done for various estuaries, some of them at broader scales. You know, we worked in many of these places already, either doing wildlife or restoration monitoring, and often what I heard is, well, sea level rise seems like it's going to be a problem. I've seen results, but I don't know what to do with that. Because either it's at a scale that was too coarse for them to manage for, or the results are projected 50, 100 years out. And often their planning horizons are much, much shorter than that. And so our results are produced in 10-year time increments. That's about, you know, as small as we can get to make sense. However, that seems to be more tangible to folks. And then again, these are the sea level rise projections we used. So Roy gave a great introduction to his refuges and slets. We decided to focus first on here. We also did his Bandon refuge. In that partnership, working with Roy and the local managers and biologists have really identified, you know, we're starting with the tidal wetlands, but like he said, it's like, well, what about the rocks? Can you help us with that? And what about the productivity or the carrying capacity for these migratory birds? So, you know, it's sort of opening up this relationship where, you know, we can partner with them, look for funding, and try to expand the project into other nearshore ecosystems that they're also managing for. So this was our study site right here. He showed some beautiful pictures of that. It's a mid to high marsh, highly diverse plant community compared to other areas. I mean, again, that's sort of relative. California has like 5 species of wetland plants that are dominant. You know, you start heading north and it gets more diverse really quickly. And these black dots are where we took sediment cores, and so all the model was calibrated to those local conditions. And I should say that my USGS field station is based in San Francisco Bay, but you know, as I showed, our research sites span the entire Pacific coast. And so these are some preliminary results. Well, they're not preliminary. These are some results out of the core data. And so Oregon State grad students and undergrads have been helping us process these. So this is some of the information that goes in. So here's bulk density, which is a measure of compaction of the soil, you know, increased with depth. And then organic content, which is a big component of wetlands being able to keep up with sea level rise, decreased with depth, as kind of you would expect, to be honest. So once we plug that all into the modeling, what we get is this first mean elevation and what happens through time with sea level rise. So years are on the bottom, the end of the century, and then the elevation, the mean elevation 0. You're really not a tidal marsh at that point anymore. You're you know, around here, you really become a tidal mudflat. But you can see mid-sea level rise. It actually keeps pace. This, Sept is a happier story than some sites. I'd be having a different discussion in Southern California. And then high sea level rise, it persists for part of the century but disappears. But really the question is this type of result relevant to management? So if I gave this to the local biologist or resource or the manager, you know, this is interesting and helpful, but maybe not as useful. So what we did is we tried to translate it into plant communities that you'll see on the ground. So those intensive plant surveys were then correlated with elevation and tidal inundation, so we could wrap it all up into these models. So we defined transition marsh, high marsh, mid marsh, and low marsh by sort of representative species, which then can be sort of tied back to the critters they may or may not care about. And then we can generate the results like this. So here's low sea level, mid, and high, with the years across the bottom, with the different colors representing the different parts of the wetland. So really, once it goes to orange, it's no longer a wetland. Light green down here is low marsh vegetation, mid and high. So you can see that with mid sea level rise, true, your wetland may still be around, but it may no longer look like what it is now. So you may no longer be managing for what you are now. And depending upon where you are located on the Pacific coast, that could have huge ramifications for endangered species, migratory birds, and other things that use these different habitat types within the wetland. So then another way to represent the results is to do it spatially in GIS. So here's broken up by 2030, 2050, and 2100. so mid-sea level and high sea level. Again, once it turns to orange, it's really no longer a wetland, so you can see this low area disappears quickly, and then the rest of it is really low marsh vegetation. And up here is the transition's much slower. But again, still around by the end of 100 years. However, the vegetation communities are probably very different because of the tidal inundation. So really what we wanted to do, and this is just an illustration of us kind of building on this project and partnering with the Fish and Wildlife Service, is there's lots of assumptions built into sort of how plants will transition through time with sea level rise. So we're doing more intense studies at the site, testing, how will increased flooding change the vegetation's sort of ability to stay there. How long can they be flooded, and does their productivity change, and kind of more detailed questions. So we deployed this last April, this is hot off the press, marsh organs, and this is a picture at Sept. So we filled it full of local plant species, and there's Fish and Wildlife Service helping us out. And we just took it out last week. So what we're able to do is that we can then better calibrate the model to talk about vegetation response, but this is also informative to them in other ways. And I'm having refuge managers call me in other places where they're using this to inform restoration targets, and also to monitor these wetlands through time, where they can then see are changes occurring with sea level rise through their site. So the data can be used multiple ways. So in conclusion, sea level rise modeling efforts vary due to sort of the input data sets and local conditions. So this investment in intensive site-specific data results in quality information for the local managers. And then establishing these baseline conditions also help the local managers in terms of, maybe they want to go back in 5 or 10 years and reassess the site and see if things have changed. And then lastly, considering shorter time steps for management, I think is really important. Thank you. And this, a lot of people.